Chapter 4.6, we're talking about isosceles and equilateral triangles. An isosceles triangle. Isosceles triangle has two congruent sides called the legs. The angle formed by the legs is called the vertex angle. The other two angles are called the base angles. You can prove a theorem and its converse about isosceles triangles. And what are those? It's if two sides of a triangle are congruent, then the angles opposite those sides are congruent. This is called the isosceles triangles theorem. Triangle theorem. And then if the opposite of that is if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So that's the inverse isosceles triangle theorem. The inverse isosceles triangle theorem. And so if we have this triangle here, well, what is an isosceles triangle? It's one where we have the two legs are congruent, and in an isosceles triangle where we have the two legs congruent, then the angles here and there, the base angles, are congruent. And then this angle B up here is our vertex angle. Our vertex angle is our B. Okay, so then we have these two theorems that we could use in our proofs, right? It's that if two sides of a triangle are congruent, we have side AB and side BC, then that means angle A and angle C are congruent. And we have the inverse of that, which says that if we have angle A and angle C are congruent in a triangle, then the sides opposite those angles are congruent, namely AB and BC. Okay, so let's go ahead and use that here. We're supposed to find x, and we're given that BC is congruent with AB. So BC here is congruent with AB. And since we know that the isosceles triangle theorem is that if two sides are congruent, which we're given, then the angles opposite those sides are congruent. So that angle is congruent with that angle, right? And so since they're congruent, we can say that measure angle C is congruent to measure, is equal to measure angle A. And then we could just go ahead and substitute the expression for C here and the expression here for A and solve for x. So we get 4x plus 5 is equal to 5x minus 10. And then we're going to solve for x. So I'm going to subtract 4x from both sides. And then I'm going to add 10 to both sides. So we get x is equal to 15. Right, and we're done. All right. And so in example 2, we're given the inverse isosceles triangle theorem, right? That the two base angles, namely angle S and angle T, are congruent. So the inverse isosceles triangle theorem tells us that the two sides here, SR and RT, are congruent. So we can create our equation. We could say SR is equal to RT, and then we can substitute in the expressions for SR, which is 3x minus 13 is equal to 2x. And then we could solve. So we're going to subtract 2x from both sides, so we get x. And then we're going to add 13 to both sides, so we get 13. And we're done. And so we're supposed to use the isosceles triangle theorem and the inverse isosceles triangle theorem to solve these problems here, and also to prove this this statement that line segment AB is congruent to line segment CB. So again, I'll show the answers to these in the next video, and I'll end this here.